Hello class, today we're going to be starting the trapezoid. So a trapezoid is a quadrilateral with one pair of parallel sides. The parallel sides are known as the bases. So the top and bottom side of this quadrilateral that is drawn have a feather on them, meaning that they are parallel, and those are known as the bases. The other two sides are known as the legs. Now the legs don't have any particular properties, they can be any size, and the bases can be any size, but they need to be sized in such a way that the bases are parallel. The other sides are called legs. They can be the same size, and if they are the same size, this is known as, it would be known as a isosceles trapezoid, which we'll talk about in a minute. Now, an interesting property is that the leg angles, meaning the angles, the two angles that are formed on one leg, are actually supplementary. So these angles are actually supplementary, and so are these. We're just going to prove that right now. So in this example, we're going to call this angle x and this angle y, and because the lines are parallel, the bases are parallel, we see our usual image for two parallel lines that have been intersected by a transversal. And these angles are on the same side of the transversal, and they are on the interior. So these are same side interior angles, just like they would be in a parallelogram. And same side interior angles are supplementary. So for that reason, angle x plus angle y will equal 180 degrees. So both angles on one leg are supplementary. So if this were 30, this angle would have to be 150. The same thing happens on the other side. So these angles are on the same side of this transversal, and they are in the interior. So they are also same side interior angles, and therefore they are supplementary. So that means if this angle over here was 100, this angle would be 80. Now this is the same diagram, so this would be 150 and this would be 30. You'll notice that the relationship on these legs has nothing to do with the relationship on these legs. There's also no particular relationship between the base angles in a trapezoid, unless it's an isosceles trapezoid, in which case there is a relationship, and we'll talk about that in a moment. But for now, what you need to know is that the leg angles, the angles on one leg, are supplementary. So, the leg angles of a trapezoid are supplementary because they are same side interior angles. Reminder, parallel lines of the transversal, one of them was acute and one of them was obtuse, so they're not going to be congruent. So let's take a look at this trapezoid here. In this trapezoid, AB and DC are the bases. So these are our bases. And we are told that the measure of angle D is 30 and the measure of angle B is 90 degrees. Find the measure of angle C and the measure of angle A. If you did this correctly, you would have seen that angle C has to measure 90 degrees because these are the leg angles on this leg, so they have to add up to 180 degrees, so C has to be 90 degrees as well. And angle A has to be 150 degrees because these angles are the leg angles and have to be supplementary as well in order for the lines to be parallel, so that should be 150 degrees. Let's take a look at the isosceles trapezoid. This is an isosceles trapezoid. It is just a trapezoid, meaning you have one pair of parallel sides, but in this case the legs are congruent in measurement. If the legs are congruent in measurement, then the base angles will be congruent. Now the base angles are the angles formed along the bases. So like the leg angles were formed along the legs, the base angles would be formed along the base. So these are base angles. So that means if this angle was 30, this angle would also be 30, which would make this angle 150 because these have to be supplementary, and then this angle would have to be 150 because these are base angles. And again, this is only true for the isosceles trapezoid. So here's another example. We have an isosceles trapezoid with its bases at AB and DC, and we are alerted that the measure of angle D is 60 degrees. What is the measure of angle A, B, C, and the measurement of side AD. Well, the measurement of angle A has to be 120 because these are leg angles, and they have to be supplementary. The measure of angle B will also be 120 because this is an isosceles trapezoid, and the base angles on this base will be congruent. Angle C will have to measure 60 because these are the base angles of this base, and they are congruent in an isosceles trapezoid. And the measurement of side AD is going to be the same as the measurement of side BC because it's an isosceles trapezoid, and the opposite sides of the trapezoid that aren't the base are congruent. Now I'm just going to prove that this is true using a little diagram so this makes sense, because otherwise you're just accepting this as true with no evidence, which we don't want to do. So the briefest explanation as to why this is true is that I can draw a, we'll call this ABCD. So this is trapezoid ABCD. I'm going to draw an additional segment here that is purposely parallel to AD, and we're going to call this BX. So that makes ABXD a parallelogram, which means that these angles, like if we said this was 30, these angles here would have to be supplementary because the adjacent angles in a parallelogram are supplementary. This angle over here would have to be 30 degrees because it's a linear pair with the angle at x. And because it's now a parallelogram, the opposite sides of the parallelogram are congruent, which makes BX congruent to BC by the transitive property, making this into an isosceles triangle. And if this triangle is isosceles, this angle will also measure 30. Therefore, the base angles are congruent, and then the leg angles are supplementary, so that makes this angle 150, and this angle will also be 150 because it's going to be supplementary to the other angle on its leg. So hopefully that is a bit clear as to why the base angles are congruent in a isosceles trapezoid. One more thing that is true, and it's because of that fact, so we're just going to scroll back for a moment here. And the other thing we need to know is that the diagonals of a trapezoid, of an isosceles trapezoid, are congruent. We're going to prove that now. We're going to prove that triangle ACD is congruent to triangle DBC. And the reason for that is they have a pair of congruent angles, because these are the congruent base angles. They have the isosceles sides that are congruent, and there's a reflexive side that they share. So the two triangles are congruent by SAS, making the diagonals congruent by CPCTC. Corresponding parts of congruent triangles are congruent. So the other thing we need to know is that the diagonals of an isosceles triangle are congruent. So the diagonals of an isosceles triangle are congruent, and the base angles of an isosceles triangle are congruent. Again, that's only true for an isosceles trapezoid. I think I said triangle when I meant to say trapezoid several times. The diagonals of a trapezoid, excuse me, all right, and there's one more property of a trapezoid we need to know before class on Tuesday, and that is the property of the midsegment. So BE in this trapezoid, ACDF, that's just reading the 4 points around the trapezoid, so that's ACDF. The midsegment is the midsegment is a line segment that connects the midpoints of both legs. So it connects the midpoints, or it's the segment between the midpoints of both legs. So in this case, CA and DF are the legs. I really should have marked that CD and AF were parallel to indicate that. And we can tell that B and E are midpoints because B divides AC into two congruent segments. And we can see that E divides DF into two congruent segments. Therefore, BE is called a mid-segment. Now, the property of the mid-segments is that the mid-segment will be equal to half of the base of the first base plus the second base. In other words, half of 10 plus 20 in this case. So that means that the measure of the mid-segment, in this case, which is BE, will be equal to 1/2 of 10 plus 20. Therefore, the measure of BE is going to be equal to 15. You can also use this idea to find the measure of one of the bases if you know the midsegment. So if I draw another trapezoid in a midsegment and said that this measurement was 100 and that this measurement here was 80, and I asked you to find this segment, you can do that as well. It would be that 80 is equal to an unknown number plus 100 when multiplied by 1/2. So what number when multiplied by 1/2 is 80? Well, 160 will be equal to x plus 100, which means that x has to equal 60. So the missing base is 60. And that's everything we need to know about trapezoids before our class on Tuesday. I will see you then.